Hi guys, here's our lesson for 14-2. The learning target is I can use the properties of numbers and operations to justify each step of solving an equation. So here justify means explaining how did I get from one step to the next step in an equation. Now I'm going to warn you in advance. Some of what you're going to see today is a lot of stuff we take for granted, stuff we do in our head, we don't think about it, but there's a lot of math behind it, there's a lot of vocabulary behind it, and that's what we're going to be focusing on today. So let's start with the distributive property. A lot of these properties are going to be familiar to you. This is a chart that I found, but I've added to it. Everything that's in color is stuff I've added to it. So distributive property, we've seen it tons of times. Okay, that's when you have a number on the outside. We don't usually see a dot in between the A and the parenthesis, but basically your outside number times anything inside the parentheses. That's super familiar to us, so I'm not going to spend too much time talking about that. Okay, commutative property. Commutative property is usually explained as if you take the numbers A and B and you reverse them and put the B first and then the A, it's the same thing. Alright, well that always seemed really Captain Obvious to me. The context we're going to be using it in is more like what you're going to see in red right here, okay? So we have 2x plus 7 plus 3x. Now, we see the 2x and the 3x and we know those are like terms. And we would just automatically combine those together. But what you're doing in your head is you're mentally rearranging these terms, 2x plus 7 and plus 3x. You're mentally rearranging so that the 2x and the plus 3x are next to each other in your mind. Okay, so here's one of those examples where we're going to be talking about things that you guys take for granted. You do them in your head and you don't think about them. But what you're doing when you combine like terms that aren't next to each other is the commutative property. And commutative property applies to multiplication. Okay, so A times B equals B times A, 3 times 4 equals 4 times 3. They're both 12. Okay, where we tend to use this in real life more is when they're not two numbers, but three numbers. So 4 times 7 times 25. If we multiply these in order, 4 times 7 is 28. And then 28 times 25, I can't do that in my head very easily. But if I rearrange the numbers, 4 times 25 is 100. So the benefit here is I rearrange the numbers and multiply things together that are easy. 4 and 25 multiply to be 100. And then 100 times 7 is 700. And that's easier to do in your head. And that's one of our purposes of commutative property of multiplication. Associative property, that's when you draw parentheses around different things. So A plus B plus C and A plus B and then plus C. So it's just moving the parentheses around. We're regrouping. We can kind of use that along some of the same lines as we did in commutative property. If it were easier to add the 3 and the 4 together first and then add the 5, you could do that. Multiplication, again, it's the same thing. Anytime you're keeping the elements or the numbers in the exact same order, 3, 4, 5, 3, 4, 5, and all you did is shift your parentheses, it's saying that we're allowed to do that. It'll still be equal. Okay, so there's a lot going on. This is a simple one-step equation. X plus 5 equals 7. When we solve that, we have subtract 5 both sides, x plus 0. Now, we don't usually write the plus 0, but that's what I'm focusing on in this part right here. Okay, so the additive identity property says that if you take a number and you add 0, you get that number back again. So that's like super Captain Obvious, right? Okay, here's where we use that, right here in this line. We don't write plus 0. We do that in our head. We know that a plus 5 and a minus 5 cancels to make a 0. But we don't write this step. We go right for the x. So a plus 0 equals a, x plus 0 equals x. We just don't write that step down, but it's there. Additive identity property. There's a lot of other properties going on in here, by the way. We'll talk about them soon. Multiplicative identity. Okay, the additive identity is 0. The multiplicative identity is 1. Okay, the multiplicative identity property says that any number times itself, or times 1, any number times 1 is itself. That's what identity is referring to. It's when the number does not change its identity. All right, where does this come into play? So it comes into play right here. All right, when we solve 5x equals 35, we divide both sides by 5, and we get 1x equals 7. Well, most of the time, I know I don't write 1x, I just skip right to the x. Okay, so here's where the multiplicative identity property comes into play. We don't write 1x, we just do it, but it's there. All right, additive inverse property. The additive inverse property means if you take a number and you add it to its negative, you get 0. Well, where does this come into play? Right here. If we have a plus 5 and a minus 5, and we combine those together, we get 0. So the additive inverse is part of solving equations. Multiplicative inverse is when you take a number and you multiply by its reciprocal, which means this is really a over 1. The over 1 is invisible, okay? But if we took any whole number and we wanted to write it as a fraction, it would be over 1. And multiplicative inverse means we take that and flip it over, and then if we multiply that together, we get the answer of 1. Now it says where a does not equal 0 because you can't have 0 in the denominator. Okay, so 4 times 1/4 equals 1. Zero property. When you do quadratics, we use the zero property to solve. Okay, if you remember, the solutions to this quadratic would be x equals -4, okay, or x equals 3. Why is that? Well, this is saying x plus 4 multiplied by x minus 3 equals 0. If I plug -4 in for this x, the whole thing becomes one big 0. And then it doesn't even matter what happens in the second parenthesis, because if I distribute a 0 to x minus 3, my answer is 0. So that's why the solution of x equaling -4 works. And that's where we're using the zero property of multiplication in algebra. Okay, the same thing would happen if I subbed in 3. This would become one big 0. And if I distributed it back to the x plus 4, the whole thing would be 0 because I'm multiplying 0 by something else. So that's where we end up using the zero property. Okay, in a simple sense, the zero property is just when you multiply something times 0, it equals 0. Now, you guys learned that in elementary school. So I want to give you a context for how we use it in algebra. Okay, closure. All right. We just talked about closure in lesson 14.1, so I'm kind of going to skip over these in our video. Okay. The next one I'm going to talk about is number 13, the addition property of equality. Okay. So the addition property of equality, all that means is if I add something on one side of an equation, I have to also add it on the other side. Okay? We do that all the time. We did not know there was a name for it, but there is. It's a property. So when we add the same number on both sides, that's the addition property of equality. Same thing with the subtraction property of equality. Here I am subtracting the same number on both sides. Okay, so the multiplication property of equality would mean that if I multiplied, remember when we were doing equations and I said if you had decimals in your equation and you wanted to make whole numbers, you could distribute through a 10 or a 100. In this case I picked 100 because it has 2 zeros and there's 2 place values in one of my decimals. So I could multiply and distribute through 100 on this side. If I do that, however, I also have to multiply by 100 on the other side. That's basically if you multiply both sides by something. Division property of equality. When I divide both sides by the same number, that's your division property of equality. Substitution property. Guys, we've done substitution like all kinds of times. You find something in, you plug it in. You know a letter, you plug it in. Okay, so we don't need to talk about that. Substitution property, we got that. Reflexive property, you do not need this for this year, but it'll come up in geometry, not with numbers, but with geometric features, like one side of a triangle will be reflexive with another triangle if they're a shared side. But don't worry about number 18, reflexive. Okay, symmetric property of equality. If A equals B, then B equals A. That's where we can switch sides of equations if we want to. 2x plus 5 equals 12 is exactly the same thing as 12 equals 2x plus 5. So if everything stays the same, but we switch sides, it's literally the same thing. And our last one is transitive property. Okay, so in transitive property, it's saying that if A equals B, okay, so A and B are actually the same thing, and B equals C, so B and C are the same thing, then A and C are the same thing. All right, so here's where we use this with equations, okay? If we have a quadratic that says y equals x squared minus 3x plus 8, and then we have another equation, this one happens to be linear, y equals 3x minus 8, okay? Down here I have a graphic. So we have A equaling B and B equaling C. Alright, I used our symmetric property of equality and I took this equation right here and I took the quadratic and I flipped it around so that x squared minus 3x plus 8 equals y. So A represents all of this stuff. And B represents the y. Okay, so now we have B, which is still the same thing as a y, equaling C. And C is going to represent all of this stuff. Okay, so if I do that, all right, I'm going to take the color away so I can keep manipulating. If I do that, okay, so A equals B, B equals C. If I make my B's overlap, we see that everything is just equal to each other. So if this equals, if I move these together, giving away my next little trick here. Okay, so if both of these things equal y, that means that I can pull each side down. Make this a little bit bigger. Okay, and they equal each other. And this becomes an equation that you can solve. So that's what transitive property of equality is going to mean. Now they give a more simplistic example up here, but again, I wanted to provide you guys with examples of properties that you would have actually seen and used. So here's some examples of the properties in action, okay? So basically we're going to start with an original problem. So starting here at the top, 4 plus 5x, 5 parentheses x plus 7. And we see all the ways that this expression has changed from one step to the next. And although we may not have write out, if I gave you this problem to simplify, you would definitely not write it in this many steps for sure. However, you would certainly do all these steps. You just don't know that you're doing some of them in your head, and you don't know that there's specific vocabulary words for them. Okay, so to get from step 1 to step 2, and I'm going to add a box here because sometimes having all of the items visible at the same time can be a little bit daunting. So what I'm looking at, before I decide what property I'm seeing, okay, so let's pretend I didn't uncover that yet. What I want to do is look at what's different from the first line to the second line. And what I see is that the 5 and the x got distributed, and the 5 and the 7 got distributed. So I see distributive property. So distributive property, now it says of multiplication over addition. I'm going to tell you, like, distributive property is sufficient. You don't need to all those words. Okay, so now the next step, I'll uncover that. And gee, what happened? What's different? Okay, well, the 4 and the 5x switched places. Okay, that would be commutative property of addition. All right, let's uncover the next step. Okay, what's different now? Well, there's parentheses that weren't there before. So I have a new grouping. A new grouping indicates associative property. And lastly, I see that the 4 and the 35 have been combined together. And that's not really a property, but the step would be called combine like terms. Okay, so if we were doing this in quote-unquote real life, all right, if I started out with 4 plus 5x plus 7, I would probably distribute 4 plus 5x plus 35. And then I would just simplify from there. I'm putting 5x first because it has a variable. And 4 and 35 make 39. So I would probably only write this in 3 steps. I would not write all 5 lines of work because I'm going to be doing a lot of this in my head. But we're writing it out and showing how the properties are used in a visual way rather than in your head, because you can't read mine. So we have to, I'm showing through visual means. Okay. All right, our next example. Again, let's just look one line at a time. Okay, so 7x plus 4 minus 3 times 2x minus 7 in parentheses. So the difference I see, let's see, 7x stayed the same. Move this over here. The plus 4 stayed the same, minus 9. Oh, here's where the difference is. Okay, I've got 3 times 2x making my 6, and 3 times, and minus 3, let's watch signs, this is a good teachable moment here. That's a minus 3 and a minus 7. So when I distribute that through, it's a plus 21. Okay, so as a step, that's going to be our distributive property. That's sufficient. It is completely not necessary to write all of those words. Okay. Our next step, let's see what it looks like. Okay, what's different? 7x plus 4, oh, that's a minus 6x. Okay, so what I see is that these two things have switched places. So anytime the order of the numbers change, that is commutative property. Okay, oh, I'm seeing parentheses or grouping has been added. These are grouped together and these are grouped together. So when we have grouping, we call that associative property of addition. And lastly, we've got x plus 25. So let's see what happened. Well, these are like terms that combined, and these are like terms that combined. So combine like terms. All right, another example. The difference between the first line and the second line is that this part got distributed. I find it kind of weird that they distributed the second half first, but oh well. Again, let's look at that plus 10. Where did the plus sign come from? Minus 5 times a minus 2 is a plus 10. Now you might be thinking to yourself, but Miss Andrews, those are subtraction signs. They are when they're part of the entire problem. Yes, they're subtraction signs. When I'm looking at the 5 and the 2 as individual numbers, we need to think of those signs as negatives and treat them like negatives. So a negative times a negative does make a positive. Okay. The next line distributes this part, the beginning. Okay, maybe they do it separate because multiplication over subtraction, multiplication over addition, but again, I really don't think you need those words. I've never heard of any other kind of distributive property, so I think we're good. All right, what's different in the next line? Let's see, they both start 4x. This one, then the next one is plus 12, and this has plus negative 5x. I don't like when they switch have a double sign, but oh well. They have changed the order of the terms. Anytime we change the order, that is commutative property. Okay, what's different? Let's see, 4x and the negative 5x combined their like terms, and the 12 and the 10 combined their like terms. That's not a property, but it is a step. Thanks for watching, and I'll see you next time.